Greetings. This week we want to take a look at recursion. Recursion is an interesting topic, and it's something that Java supports, and we're going to take a look at it this week. We want to first understand what recursion is. Then we want to be able to use recursion to solve our problems in Java. We want to be able to do, today in this video, we're going to create a solutions for a simple problem, that of calculating the factorial of a number, in a recursive fashion and in an iterative fashion. It turns out that this is not the only two cases, but these are the two that we're going to take a look at in this brief video. First of all, what is recursion? Recursion is a technique in which a method, or in general a function, directly or indirectly calls itself. It's self-referential. This recursion requires us to think in a new way. We want to learn how to think recursively. When you approach a problem, recursion techniques might not be your first thought, but this week we want to explore it. Okay, Java supports recursion, although all languages don't. So that's one reason we want to take a look at it this week. Many of the problems that you approach when you might consider recursion would have an iterative versus a recursive type solution. We'll talk about both of those. Okay. One of the things that we're going to have to do is understand that we're going to almost have to assume that our method, or our recursive method, exists already before we actually write it, and then in the method we're going to actually call the method itself. It's an approach that the mathematicians take quite often to solve problems. And in general, we're going to take a problem that's not directly solvable and break it down into parts. One of those parts is going to use our solution as a part of the solution. That's where the self-referential part comes in. Okay, what do we want to take a look at? Let's use factorial as an example. Factorial is a common math function used in many applications. The factorial of an integer is written as x exclamation point. What it really means is, if it was 4, it would be 4 times 3 times 2 times 1, which is 24. So that's what it is. Okay, let's open up Eclipse and take a look. I've got my Eclipse opened up, and we're going to try and create an iterative and also a recursive solution to the factorial problem. Now, before we start, let's make a couple of points that the book makes. In general, when we want to solve a problem recursively, we have to break it down into parts. I'll say two parts: an easy part, and then an easy part, or a terminal part, and then also a self-referential part. Hopefully it'll be a little bit more easier to understand when we take a look at our factorial. So every recursive call, one that calls itself, must simplify the computation in some way. And there has to be a simple case, base case, that can be easily solved. In this case, the factorial problem, the factorial of 1, or even of 0, is by definition 1. So that'll be our simple case. Okay, that's the problem. We want to solve the factorial problem recursively first. Okay, so let's create a Java project. File, new Java project. I'm going to call it factorial. I've already set up my project defaults. Now, there's several different ways we could be approaching this. I'm going to take one that's probably not the best approach, but I think it'll be the most instructive for what we want to do. First, let's create a new class called factorial. Okay, we want to have a instance field, an integer, private int, let's call it number. Next we want to create a recursive method, or no, let's make a constructor, public factorial, and it's going to take an int I'm going to call it num as a parameter, and I want to save that num in number. Okay, now and then it should have a recursive get factorial method. I'll make it public. It should return a long. These things will get pretty big pretty quick. Get factorial. Now, its job is to return the factorial of whatever number that was passed to it in the constructor. This is where all of our calculations are. Okay, so what do we mean by self-referential? Well, we said we have to have a simple case, and I'm going to say that's going to be if the number is 0 or 1, so I'm going to say if it's less than 2 for simplicity. I just want to return 1. That's our simple case. You have to have a simple case for a recursive solution. Now if it's not going to return 1, it's going to be the more complicated case. So what I'm going to do, okay, what's the factorial of a number? I'm going to let's see, I'm going to create a another factorial object of 1 smaller than num. Factorial f is equal to new factorial of number minus 1. And then I'm going to return the number times the factorial of f. I'm going to return f number times f dot get factorial. Okay, that's basically the recursive solution. If it's a simple case, return 1, else create a new factorial and return the factorial of that. Notice that inside of get factorial, we're calling get factorial. Okay, now, what else does it say? Okay, we should create a tester. Okay, so I'm going to go over here and I'm going to say file, new class. I want to make factorial tester, and I'm going to give it a main method so I can run it. And what am I going to do inside of this tester? Well, I'm going to create a scanner. Okay. Got to add the import. Eclipse helps me out with that. Now I'm going to ask the user what number they want. I'm going to say int number is equal to in.next int, and before I ask for that, I'm going to prompt the user. Okay, now I'm going to make a factorial object. fact number. Now my object fact should be able to tell me what the factorial is. I'm going to say create a long, because that's what it's going to return, could be large, is equal to fact dot get factorial. Notice in the tester I don't know how factorial is going to do it, or get factorial is going to do it, but we're just calling it to get the answer. Then I'm going to display the answer. The recursive is okay. Now let's give that a shot and see what happens. Let's run that, see if that works. We know that the factorial of 4 is 24, so let's see what happens. Enter an integer. I'm going to enter 4, and the recursive factorial is 24. So that actually works. Let's take a look back at factorial, and there's the code. There's factorial. There's the recursive code for getting a factorial. Now let's create another method to do it iteratively. We want to have two different ways to do this, so I'm going to say we have two different solutions. One is recursive, one is not. They're both going to do the same thing. That does not mean that one for any particular application is better than the other one, but we're doing this just to make it a to illustrate one of the simplest factorials we can. Okay, so now what do I want to do? I want to say, after I've displayed the recursive one, I'm going to set answer equal to fact dot get factorial iterative. I'm going to do it the other way. And then I'm going to say the iterative factorial is answer. Okay, let's see how that works. And I'll run that. Whoop, I have an error here. Okay, this probably hasn't been saved yet, so I'll save that. Okay, after I've saved both of them, it compiles. I'm going to be saying the iterative factorial is answer, where answer is now get factorial iterative. I'm going to run it. I'm going to try it with 4 again. And we come up with the same answer either way. So, what have we done? We've done a brief example of doing a recursive and an iterative solution for the factorial. I'm not saying that recursive is better. I'm not saying it's worse. Some applications it'll be better. Sometimes it won't. In other parts of this week's material, you're going to see a Tower of Hanoi solution. I couldn't come up with an iterative solution to that, but I could come up with a recursive solution. Some problems will be amenable to the recursive approach. There's a lot of discussion over the efficiency of recursion. Next week we're going to talk about sorts, and you're going to find out that actually a merge sort is a recursive solution, and it's a very efficient algorithm. So recursion can be efficient, so don't automatically disregard it out of hand. The other point I wanted to make, remember, 2 key requirements for recursive success. 1, every recursive call must simplify the computation in some way. In other words, factorial of n minus 1 is simpler than the factorial of n. And there must be some special terminal simple case to handle the simplest computations directly. Okay, that's the end of this video. Hopefully you've gotten the idea that we can solve recursive or iterative solutions.